Hello, in today's lesson, we're going to be exploring balanced, unbalanced, and net forces. Basically, we're going into Newton's first law more in depth to kind of really fully understand it. You need to continue your notes, please, on page 11, where you had them before. So under where we've written for motion and inertia, please continue these notes. We are using the outline style of note right now, okay? Right here, outline, as opposed to the Cornell style of notes that has been previously used. But this slide here is an excellent spot to notice the comparisons of how Cornell notes and outline notes translate back and forth. Feel free to pause the video here and have a closer look. Okay, so just erase that here. What we're looking at right now is we're looking at just a quick review. What is a force? So force is a push or pull, okay? For us, normally a force is going to cause a change in motion because we are specifically looking at forces in motion. However, generally speaking, an object is not always going to be in motion, so we are just looking at what are the pushes and pulls that are on that object. Okay, once again, how do we know an object is in motion? It is changing its position, okay? So it's changing where it started and where it finishes. Oops, sorry, I'm getting used to this mouse here. And the way that we do that is by using a reference point. So the reference point tells us it's the location, or it's what we compare the movement to. Okay, so it's a specific location that we can compare another object to see if it's actually changing position or not. All right, then next, if we keep going. Sorry. Okay, the learning intention today is to plan an investigation to provide evidence that the change in an object's motion depends on the sum of the forces. So it is still the same learning intention that we've been doing before. Success criteria is to describe balanced, unbalanced, and net force, to compare situations to determine if forces are balanced or not. That will be done in class, and to calculate the net force. So, lesson objectives. I can take notes on and describe balanced forces, unbalanced forces, and net force. That is what is currently happening in this video. Afterwards, in class, you're going to be doing different activities to compare situations, to practice problems, to identify forces, if they're balanced or unbalanced, and also to calculate the net force. So, before we begin, a couple of things that are really important. Forces. All forces have what we call a magnitude and a direction, okay? So the magnitude, or the size, is the amount of force that there is. So we normally measure that in newtons, okay, with this N here, and that's a number value. So it could be 5 newtons, 10 newtons, 100 newtons. That is the magnitude. The direction is simply which way the force is acting. Is it going up, to the left, down, north, south, east, west, etc. Okay? So, before we go further into balanced and unbalanced forces, I just wanted to do a quick review on the two main types of forces that we have, which are contact forces, here, okay? And those are when the force is acting on an object by physically touching it, as well as non-contact forces. Non-contact forces is when the force acts on an object without actually touching it. Okay? So a couple of examples of contact force. We've got if you're pushing or pulling or carrying something and you are actually touching the object. If you're pulling on a rope, even if you're technically exerting the force on somebody else, because you are touching the rope and the rope is exhibiting or exerting a force, that is considered a contact force. Tension is a type of contact force. So when something like a rope is stretched out, that is a contact force. Okay, and then we've also got the force of friction. which is over here, a force that opposes the movement or the motion of another object. And that's caused by when things rub together. So it is a contact force because the two objects need to touch. For the non-contact forces, there's three big categories that we're going to focus on. And those are gravitational force, caused by the different masses and the attraction between two objects. We will go into that in a later unit. Magnetic force, okay, again, an attraction from a force field that causes a change in another object. And the last one is static electricity. And that is another type of force that can occur that is non-contact. So, for us, we are focusing on whether forces are balanced or unbalanced. Balanced forces happen when all forces acting on the object are equal in size and opposite in direction. Basically, they cancel each other out, and we end up with what we call a net force of zero. You can see that here in this example where we have gravitational force pushing down on the man and the buoyant force from the water pushing up. The arrows are all the same in size, but opposite in direction. Okay, here's a few more examples of balanced forces. Feel free to pause the video to have a closer look. So the skateboarder has 100 newtons pushing backwards with air resistance and 100 newtons pushing forwards with what he pushed. Okay, a person standing has force pulling down on them, but the floor is giving the same amount of force back, which keeps them in the same spot. Okay, this one here, a truck moves. If you're pushing it forward and your friend is pushing it back with the same amount of force, the truck stays still. And that's actually the main part that we need, is to understand what happens to motion if forces are balanced. Okay? It's pretty easy. According to Newton's first law of motion, the motion will not change if the forces are balanced. So if an object is not moving, it will not start moving. But if an object is already moving, it will keep moving at the same speed. Okay, so balanced forces equals no change in motion. All right? If you want to change the motion of an object, so if you want to make something start moving, or you want to make it move faster or slower, then you need to apply unbalanced forces right here. Okay? Unbalanced forces are when the forces are not equal. This will always cause a change in the motion of an object, okay? Either by changing the speed or the direction that the object is moving. A couple of examples of unbalanced forces. Here you've got somebody pulling with 30 newtons and another one pulling with 50. The one with 50 is going to win. Okay, the bird is diving with a weight of 25 newtons, which is the force of gravity, and the air is only providing 16 newtons of air resistance, which means the bird is going to fall. Okay, we've got our cart as well here in this section here, 3 newtons pushing to the left, but 8 newtons pushing to the right. You might ask, why did I say 8 newtons? Well, that is the net force. So the last big thing that we're looking at in this lesson is the net force. And it's basically the sum of all of the forces acting on an object. The way we find this is by looking at the direction of the force. So any forces that are moving in the same direction are going to be added up, okay? So for example, here we've got 5 newtons going to the right and another 5 newtons going to the right. We can add that up to equal 10 newtons to the right. 5 newtons to the right plus 10 newtons to the right, because they're going in the same direction, we add them up, okay? However, if the forces are going in opposite directions, we are going to subtract them. So here we've got 5 to the right, 5 to the left, which gives us 0. Okay, same thing, 5 to the right, 10 to the left. 5 minus 10 gives us minus 5. Just to finish up, basically the direction is important when finding net force, so we often give them a positive or a negative. Okay, that is it. We will do some activities in class to finish